Good afternoon, everybody, and welcome to today's free cloud webinar, Navigating the Landscape of Today's Cloud World, brought to you by Pluralsight. Cloud is becoming the core of more and more organizational strategies globally. There are some key benefits that come with cloud, but organizations also need to plan their migration journey. However, it can certainly be overwhelming navigating through the various cloud offerings available to us today. So today, with the help of our very special international guest, we will discuss the benefits of cloud migration, cloud categories of offerings and infrastructure, key providers and their offerings, and upskilling your cloud development engineers. Hello to each and every one of you. My name is Shobit Khanna, and I'll be your moderator today. Now, we still have some people joining us in the back rows, so while they do that, let me take you through a little bit of housekeeping. Now, please note that all attendees are in listen-only mode. However, we do encourage you to interact with us today. You can do so by using the Q&A panel at the bottom of the Zoom window. We will do our best to get to all of your questions towards the end of the webinar. Also, we love getting feedback from you, so I would like to bring your attention also to the exit survey, which you'll receive as a separate email at the end of the webinar. We would love to get your feedback about today's session as well as future topics you would like to hear about. Okay, now that all the housekeeping's out of the way and everyone's settled in, let me introduce you to our special guest for this evening, or this afternoon, her evening, Sandra Medina. Sandra is an applications architect and an author at Pluralsight. Her experience in cloud computing started at Microsoft, where she was a software engineer in Azure. There, she contributed to an internal service that currently runs across the Azure fleet of servers and which helps engineers debug their service crashes and improve performance. Since then, she has also used AWS services and a variety of third-party tools to create robust, elegant, and scalable solutions for her clients. So without further ado, I'd like to hand it over to Sandra, who's joining us during her evening time from the US. Welcome, Sandra.
Hi, thank you, everybody. Thank you for being here. I'm going to go ahead and turn my video off just so that you're not so distracted by me and can focus on the content. And I'm really just going to jump right into it because we have quite a bit to cover tonight. So here we go. All right. Okay, so today we're going to be covering three main topics and trying to stay at a very high level and not really get bogged down in the technicalities of all the various services that cloud providers out there offer, because there are truly a ton. But first, we're going to cover potential benefits of cloud migration. We're going to cover the main reasons an organization might choose to undertake the potentially big task of moving to the cloud. Next, we'll do a comparison of cloud providers and offerings, again, trying to stay high level and only covering a couple of providers and some of their core services. The goal is not to understand the inner workings of every service and how they all connect together. It's more to get a sense of the variety of offerings and start to familiarize yourselves with their names and basic functionalities. And last, we'll look at migration strategies and tools. This section will give you some ways of helping you decide if a cloud migration is right for your organization, so you can feel more confident in your choice. It will also talk about what tools are available if you do decide that move is right for you. And we'll look at some high-level strategies to keep you and your teams on track throughout the move and help the group be successful during the move and into the future. Okay, so let's begin by looking at the potential benefits of cloud migration. First, I'd just like to share my general stance on this, which is that while migrating to the cloud may not be right for every business, there are many reasons why you should at least consider it and conduct the relevant assessments. So let's take a look at those potential benefits. I say potential because whether or not these benefits will apply to your organization depends on a lot of factors that you'll have to examine and consider yourselves, but this will hopefully give you an idea of what's possible. The first potential benefit, and a critical one to most organizations, is cost optimization, whether you can save money by moving your infrastructure and workloads to the cloud. Up until now, costs were sometimes comparable between staying on-prem and embarking on a cloud migration, which meant that the risks associated with a migration were sometimes not worth it for some larger enterprises. However, now with cloud costs continuing to decrease, the move may be a lot more appealing. So in terms of savings, it's not unreasonable to expect infrastructure costs to go down in the range of 30% or so, and that's based on migration data from cloud providers. So let's look at some strategies to keep costs low. First, right-size resources. There are tools that exist that help you determine which resources are being underutilized. And when you notice that that's the case, you frequently have the option of reconfiguring, consolidating, and scaling down your resources. This can result in big cost savings because you're not running those mega high performance machines for, just small jobs. Next, consider the ability to power off idle resources. Cloud providers offer a variety of tools to help you identify which resources are being idle, just like really not being used at all. And you can use these suggestions to know when it's time to shut something down entirely. Before you decide to shut something down, these tools usually help you forecast what your savings will be, so you'll know what that looks like. Next is auto-scaling, which is a huge draw toward cloud computing and can also lead to cost savings. This is because you only scale up your resources when your traffic and demands mean that you need to. If you're getting more traffic, you are probably also getting more customers and revenue. So you probably don't mind needing to scale up. It's usually a good problem to have. And the way this works is that the service is tracking the load, and when it gets to a certain threshold, it will dynamically allocate and deallocate resources for you. Cloud providers also give the ability to reserve resources in advance. This means that for certain resources, if you know you're going to need at least a certain minimum capacity based on your historical data, you can reserve those in advance for additional savings. And reserving servers and other resources in advance can provide a significant discount, up to like 75% sometimes, compared to on-demand capacity. And plans for this kind of thing are usually on something like 1 to 3 year terms, but that can vary. Next, consider your ability to choose just the right service in the cloud. There are so many services out there, so you want to invest time in choosing the right ones, especially for things like compute. This is because you want to pick the most cost-efficient solution based on your actual needs. Frequently, you can cherry pick and leave out what you don't need. And lastly, you can rely on billing alerts that are set up in your account. You can set these alerts up to let you know when you're reaching your budget threshold, and those alerts can reach out to your team or do some action in response to the event. For example, not scaling up anymore or even scaling down. And cloud providers also make it really easy to monitor and analyze your spending with a lot of data analytics. Next, let's consider the potential benefit of efficiency and productivity. This is slightly more difficult to measure, so I would take these figures with a grain of salt, but still they're quite impressive. In recent studies, cloud providers boast numbers like 60% increased productivity of IT staff and 25% increased developer productivity. One reason for this is because moving to the cloud often allows tasks to be simplified. Your teams will see easier patch automation, scaling, monitoring, deployment of storage and compute, automated security, testing integration. These are important core tasks, but they are often time-consuming and tedious. Another explanation for this increased productivity is the cloud's ability to facilitate more agile development. This is especially important right now, where global current conditions are forcing a race to see which organizations can adapt most quickly and adjust their business models. A lot of you might be feeling this right now in your own organizations. We've seen this year just how unexpectedly things can change, and the quicker you can adapt to that, the more responsive your business is to changes, and the more successful your business will be. With cloud development, you're able to roll out more features in less time by using the suite of tools and frameworks provided to you. And you're also able to deploy faster and have more sophisticated DevOps practices. Cloud development enables you to iterate with more ease because cloud infrastructure is inherently less intertwined, has fewer cross dependencies, and is more decoupled. And it's also easier to do things like A/B testing to see what your customers respond to best. Increased efficiency also comes from your engineers' ability to focus on higher value activities after a move to the cloud. One main reason for this is that they no longer need to worry about quote unquote metal issues. This can be especially nice if your engineers are currently working from home right now. If you do have hardware that is toward the end of its life, you can consider retiring it, recycling it, or even donating it, perhaps to local schools or nonprofit organizations. By spending less time on maintenance of both hardware and software, engineers have more time to identify and address new business opportunities. And a greater emphasis on business-focused projects means more revenue-generating innovation. And also, on a note of personal opinion, I think working with modern tooling just makes for happier devs, and that can lead to a more productive environment. The next potential benefit we'll consider is increased uptime. Across the various cloud providers, I guess the potential benefit is really reliability, but part of that is increased uptime. Across the various cloud providers, expect uptimes to be in the range of 99.995 to 99.9987% and up. With these providers, you'll have guaranteed SLAs, also known as service level agreements. This means that they are required to maintain a certain level of uptime and availability of your resources. And if they don't, what they usually offer in the contract is cloud resource credits, which you can apply toward your bill. It's important to note that outages do happen, but these companies are in the business of availability. Their reputation is at stake, and when something goes down, everyone is watching. Another way that cloud computing offers reliability is through redundancy. An example of this is when your data is replicated across different geographical regions. This can be important if there's like a literal physical disaster in a region, natural or otherwise, and that compromises your data. You can also set up your applications to be geo-distributed. And if you do this, you can deploy your app in multiple regions and then reroute when necessary. And there are various other methods of disaster prevention and recovery, such as restores and automatic backups, which are usually simple to set up. And another big benefit of cloud development is the ability to set up alerting across a wide variety of metrics. Cloud providers are going to have extensive alerting systems that you can set up to let you know if something is wrong or could go wrong soon or is suddenly just really, really wrong. You can decide what metrics you want to monitor on, and they will also recommend metrics based on what services you're using. You can also employ AI modeling to try to predict when something might be about to go wrong based on past history that the service has about your application. And the final benefit we'll look at, and is maybe one that some of you have concerns about, is security and compliance. On the security front, major providers are going to have a global presence, and they're going to adhere to strict security programs. In some ways, the cloud can be more secure than a private data center. In a 2019 study, Stripe surveyed 800 businesses and found that, quote, using public cloud-based payments infrastructure cited improved security as the #1 benefit they've realized from implementation. Advantages that they found included the fact that cloud providers have the resources to stay on top of threats, the fact that they have seen many threats and are battle hardened by it, and the fact that they have the type of modern infrastructure that they need to be the most resilient to threats. So unless you really need to keep something locally on-prem without access to the internet, like election ballots maybe, or something like that, you really can't reach full compliance with your cloud provider, you might be better off in the public cloud. Remember, you're going to have layers of security across the physical data centers owned by the cloud providers and their infrastructure in those data centers, as well as across operations. And there are going to be probably thousands of security engineers working for your provider and thereby indirectly working for you. By simplifying how security works, cloud providers can help you leave fewer backdoors open to attacks. The simplification works by giving you centralized insights and recommendations all in one place, built-in security tools at every level of the process, and strict and clear identity and access control that is easy to manage. And perhaps just as important is compliance. One thing to realize is that cloud providers have an incentive to be as compliant as possible because they want to appeal to as many customers as possible. This means you'll have a wide range of compliance certifications and standards to choose from, and built-in tools to help with implementing them. These tools will target such things like data retention and purging, logging, geolocation, and so on. Now we'll move to the next section, which is going to look at a few of the major players in terms of cloud providers as well as their offerings. Remember, major providers are going to have a lot of similarities across their basic services. That includes flexible compute, storage, networking, and they'll also have the important elements of any cloud. That means instant provisioning, auto scaling, security, compliance, access management, and so on. Again, we're not covering all the offerings today. That would be quite impossible. In every category, there are going to be more offerings than what I'm discussing. We're just looking at some of the popular ones to give you some breadth. And we'll focus on compute, storage, and databases, and we'll mainly talk about AWS and Azure because they do hold so much of the market share, but I might also try to breeze through the Azure part depending on time. Before we do that, let's briefly discuss from a high level the various categories of cloud computing. This chart is a general guide, and there might be some discrepancies and outliers. For example, you might have Linux containers running in isolated partitions on a Linux kernel instead of a traditional hypervisor. But for the most part, this should give you an easy way to see how these categories are divided. First, on the left is the on-prem solution. This is probably what you're most used to now. With the on-prem solution, you're responsible for everything. That means physical location, purchasing, maintenance, updates, all of it. And now we'll move to the far right of the chart, which is SaaS, or software as a service. SaaS is the opposite end of the spectrum. With SaaS, users connect to cloud-based apps over the internet. Examples of this would be like Office 365, Salesforce, Slack, etc. In this case, you aren't responsible for any part of the stack, you're just the consumer. And the software here is stored on the service provider's network, and so is your data. And now we're going to start moving left. And we land at FaaS, or functions as a service. If you've heard of serverless computing, that usually falls under this category. With this, you have zero infrastructure management. To be clear, your servers are still running your code. It's just that you're not worried about those servers at all. That's the cloud provider's job. There are several different serverless patterns that exist. One of them is called serverless functions. This pattern uses an event-driven model. The functions are triggered by events that execute the code, and they use bindings to integrate with other services. In this case, you pay per execution of the function and not more than that. In this model, your focus is on the application client and the backend business logic. That is what that orange functions layer here is referring to. This could look like writing individual functions in Python, for example, or some other language, and then you just paste those and configure them right in the service provider's web dashboard. Or you could use a framework to help you do this. With this model, infrastructure automatically scales up and down within seconds usually. And one trade-off is that you might see some latency over PaaS, which we'll talk about next, but caching can help with this. So moving to PaaS, or platform as a service. In this category, application refers to your complete web application, including the full traditional backend, like a Python Flask app or something like that. However, your development and deployment environment is in the cloud. You'll have resources built in that help with app delivery, and you'll purchase those from the cloud provider and access them over the internet. And database management systems are also included in the resources you can purchase. According to Microsoft, PaaS is designed to support the complete web application lifecycle: building, testing, deploying, managing, and updating. What you don't need to worry about are things like software licenses, middleware, container orchestration, or management of the development tools and resources. You just worry about building your app. Next, we'll look at CAS, or containers as a service. For a little background, a container is just an executable unit of software in which application code is packaged, and it's packaged with all the libraries and dependencies that the code needs in order to run. And your responsibility in this category starts at the container layer, which you run your applications inside of. You can upload, start, stop, organize, scale, etc., your own containers. However, usually you'll work with some kind of container orchestration platform to help you do these things. And finally, let's look at IaaS, or infrastructure as a service. In this case, you're renting VMs that run on top of a hypervisor, or what's also called like a VM manager or monitor. And these VMs are called guests. What's nice is you don't need to worry about the hardware or the hypervisor itself. You also don't need to worry about physical networking, power, or storage. However, you do usually need to configure virtual networking and storage. You're also going to purchase, install, configure, and manage your own software, including the operating system. And so as you can see, you still relatively have a lot of responsibility in this category, but IaaS does still scale up and down quite easily. And just to go back to the topic of security briefly, I'd just like to take a moment to mention that security is a shared responsibility in the cloud. The cloud provider is responsible for security of the cloud, and you are responsible for security in the cloud. And we can talk more about security at the end if there's time, but that's just a general point to remember. Now let's take a minute just to consider the three main cloud service deployment options, starting with the public cloud. In this case, all cloud resources, servers, storage, etc., are operated by a third-party cloud provider, AWS, Azure, etc. Your resources are delivered over the internet. The hardware, software, and supporting infrastructure are owned by the third party. And importantly, you share these resources with other cloud tenants. You're going to be on the same physical servers as these other tenants or customers. You'll get web browser-based access to services and to your account. And some major benefits to this are low cost, low maintenance, high scalability, high reliability, and you just get a huge network of servers that are great for resilience. And the next option is the private cloud. In this case, you are the only tenant. These resources are used exclusively by your organization. No one is sharing that server space with you. As far as location, this can be either physically located at your own data center, or it can be hosted on an independent cloud provider's infrastructure or built on rented infrastructure housed in an offsite data center. This scenario has various management models, which include managing everything yourself as the customer or outsourcing management partially or fully to a service provider. Also in this scenario, your services and infrastructure can be on a private internal network. And this model is usually used by mid to large size organizations in fields like government and finance, that is business critical organizations that need a lot of control and privacy. This model is more customizable, but it's also more responsibility for your organization. And finally, we have the hybrid cloud approach, which is a mix of the two. In this case, you have an integration of public and private cloud or on-prem infrastructure. You're able to put each application in its own optimal environment, and you're able to choose based on the workload where you want it to live. You can use tools to help you move these workloads fairly seamlessly from one environment to the other if you need to. This model can be the best of both worlds for some organizations, because on one hand, you're able to keep your highly sensitive, highly performant workloads and workloads that can't be easily migrated in the private cloud. And then on the other hand, you can use the public cloud for everything else, more storage and compute capacity, and so on. And you can also use a technique called cloud bursting, which is when you keep things in the private cloud until there is an uptick in traffic or data, at which point it bursts out of the bubble and into the public cloud. Okay, now we'll talk about specific providers and their offerings. We'll start with AWS and the potential pros of this provider as a candidate for your organization's cloud move. So one potential pro of AWS is just its immense chunk of the market share. By the way, these market share values are from 2018, they're from Gartner. But yeah, it's pretty clear that AWS has a really big advantage here. Another potential pro is that they have a 7-year head start in the cloud game. AWS was building the cloud for 7 years before anyone else even started because they saw the opportunity here. This just means that they've been at the game longer and they are the most mature just by sheer number of years of experience. This maturity plays into the next potential pro, which is their breadth and depth of offerings. They have over 175 different offerings, which span a wide variety of services and tools for their customers. Moving on to some potential cons. One is that they We're a little slower to embrace the hybrid model of cloud development. However, AWS is now coming around to the hybrid approach and offering more services in this area. So it's also something we'll look at more in a later slide. Next, one potential con might be that their large number of service offerings could actually be kind of hard for you to navigate. If you look at the drop-down menu in the AWS console, you'll see a ton of services, and this can be a little overwhelming at first. And this point probably only applies to some of you, but it's worth noting that your company may be competing with Amazon in areas like healthcare and financial services, so maybe you don't want to give them all your money. Now we'll look into some of their actual offerings, and the first category we'll start with is compute. And before we start, just one note on naming. AWS sometimes uses AWS in the name, sometimes Amazon, sometimes nothing in the name. So it might look like I've listed these down wrong, but I promise I've tried to be consistent where possible. So first is Amazon Elastic Compute Cloud, also called EC2. This falls into the category of infrastructure as a service, or IaaS. Here you have virtual servers in the cloud with resizable capacity. You're able to choose your processor, storage, networking, OS, and purchase model. Next, we have Amazon Elastic Container Service, or ECS. The service gives you that fully managed container orchestration platform that I mentioned earlier that you might want for help managing your container instances. This service is heavily used internally to run AWS. So for that reason, you know it's been tested extensively. And it also offers native integration with other core AWS services. AWS Lambda is the next service, and this is under the serverless or functions as a service category. Here you get compute without servers, you pay only for what you use, and scaling up the functions is triggered automatically based on the events that are coming in. And the functions can also be triggered by other AWS services or called directly in your web or mobile app. And next we have AWS Outposts. This is part of AWS's hybrid solution. Here servers are delivered to you by AWS to your premises. Then you're able to run AWS infrastructure and services from wherever you are. According to AWS, this is ideal for workloads that require low latency access to on-prem systems, local data processing, data residency, and migration of applications with local system interdependencies. Moving on to storage, we'll look at AWS's most common storage solution, S3. This offers an object storage solution for pretty much all scenarios and sizes, and offers variably priced classes based on how frequently you need to access data and whether you want any archiving. So for example, one of these classes is S3 Glacier. It's very low cost and very durable and good for infrequently touched object storage and backup. It also offers 11 nines of data durability, and backups are automatically created across multiple systems. Another storage solution is Amazon Elastic File System. This is a cloud file storage solution and gives your servers access to a shared file system. This can be used with other AWS cloud services and on-prem resources. It also scales on demand without the need for additional configuration. And another storage solution is Amazon Elastic Block Storage, which is frequently used alongside the first compute service we looked at, Amazon Elastic Compute Cloud. And it's built for mission-critical intensive workloads. With this solution, files are broken down into what's called blocks and then uploaded. And each block is given an address, but it doesn't have any metadata. Finally, we have Amazon Storage Gateway. This is a hybrid cloud storage solution which lets you access cloud storage from on-prem devices. According to AWS, it helps with moving backups to the cloud, using on-prem file shares backed by cloud storage, and providing low latency access to data in AWS for on-prem applications. And lastly, we'll look at database offerings, starting with Amazon Aurora. Amazon Aurora is a relational database offering that is compatible with MySQL and PostgreSQL. It is reportedly up to 5 times faster than standard MySQL databases and 3 times faster than standard PostgreSQL databases. To manage it, you can use another service called the Amazon Relational Database Service, which helps to automate many tasks such as hardware provisioning, database setup, patching, and backups. Next is Amazon Redshift, which is a cloud data warehouse. It's reportedly the most commonly used cloud data warehouse. For this solution, you'll use SQL to query your data warehouse, and you can save to S3, the storage solution, for more analysis later. By the way, the name Redshift means a shift away from Red, aka Oracle. And the last AWS offering we'll look at is Amazon DynamoDB. This is a NoSQL database offering that relies on key value pairs and documents and tables. It is extremely useful for high traffic apps, gaming, e-commerce, and so on, and it offers low latency data for pretty much any scale. Now here's just an overview of AWS's compliance certifications and programs, which you can see from a glance is quite extensive. They have GDPR, HIPAA, broken up into different regions, and yeah, just you can see that it's something they clearly care about. Okay, now let's move on to Azure. And the first potential pro for Azure is the same as AWS. It has a large part of the market share at 16%, which is significantly smaller than AWS, but it's still number 2 in the running, and that is meaningful. Another potential pro will apply if you already have a relationship with Microsoft. If you rely on services like Teams, Office 365, etc., then everything for you will be all in one place. And also, if you're running Windows Server or SQL Server, you could be looking at significant savings by going with Azure. At the same time, they're still friendly to open source technology. Today, about 50% of workloads in Azure are running on Linux. Before I get into the potential cons of Azure, let me just make a disclaimer that the things I'm mentioning here are not the things I observed while working there. They're exclusively done from doing research for this presentation. So moving on to potential cons, the first has to do with outages. So in 2018, AWS had an uptime of 99.9987%. Google had an uptime of 99.9982%, so that's slightly less. And Azure had an uptime of 99.9792%, which is slightly less than Google. So this difference is quite small, but it is significant. However, this might be influenced by the fact that Google is not running at the same scale as Azure. The next potential con is that Azure is going to have fewer customers than its main competitor, AWS. Because of this, there may be less testing in the wild, so to speak, and fewer people on the forums and so on. However, Azure still does have a lot of customers, and you'll be in good company if you choose them as a provider. And finally, Azure is considered by some to be more enterprise focused. Because of this, their offerings may be catered toward enterprise companies using a suite of Microsoft products, people buying package deals, and so on. This could be an advantage for some people, depending on if you fall into this category. Now let's look at some of Azure's main offerings, starting with compute. The first is virtual machines, and these run Linux and Windows and are suitable for high performance and mission critical computing. You can use your own VM images or get them from the Azure Marketplace. Next is Service Fabric, which is used to scale and orchestrate both microservices and containers. This can be used with Linux or Windows, in Azure, on-prem, or even in other clouds. With this service, you don't need to worry about latency, scaling, availability as it relates to your containers. Service Fabric also powers a lot of core Microsoft products, Skype, Dynamics 365, Cortana, as well as just Azure internal infrastructure. So again, you know, it's been well tested and vetted. And it's also an open source project. Next is Azure Functions, which is Azure's serverless functions as a service offering. The service is stateless by nature, but can be made stateful with something called Azure Durable Functions. This is an extension that lets you do things like function chaining, which is when you can use a pattern where, for example, you take the output of function A and make it the input of function B and so on, and kind of chain in that way and make it stateful in that way. Scaling here is automatic, and you use triggers and bindings to respond to events similar to AWS Lambda. And here you also get an integrated building and debugging experience. You can do this locally on platforms like Windows, Mac OS, and Linux. Also, if you use VS Code as an editor, there's an Azure Functions extension, which makes development a little easier. And then we have Azure Dedicated Host. These are physical servers dedicated to your VMs. Here you don't need to share capacity with other tenants. And this can potentially help if you have strict compliance requirements. With this service, it's important to note, though, that maintenance policies are going to be up to you. Okay, now moving to storage. The first storage offering from Azure we'll look at is disk storage. You can use hard disk drives, which is the lowest tier class, or solid state drives, which are the upper 3 tiers. This is another service that uses block storage, and it can handle unexpected traffic on smaller disks by using burst capabilities. The top tier specifically has really dynamic scaling and is highly durable. Next is blob storage. This form of storage is highly optimized for data lakes. It also works well with serverless architectures because you can have functions that actually react to changes in blob data, as well as functions that read and write to storage. And this offering has automated lifecycle management. It will put your data into different tiers based on how often you want to access it or whether you want it to be archived. Now we have Azure Files, which is for cloud file shares. The service can be mounted onto deployments of cloud or on-prem Windows, Linux, Mac OS, and it allows file sharing between apps running in your VMs. In this scenario, there is no server to manage. And the last storage offering is archive storage. This is specifically for data that isn't frequently accessed. In this case, data at rest is automatically encrypted, and it can give you terabytes of data stored at really low cost. Moving to their database offerings, we'll start with Azure SQL Database. This comes with automated updates, provisioning, and backups, and you're always going to have the latest version of SQL. It has a serverless compute tier offering, which automatically scales compute based on workload and automatically pauses databases during inactivity. So in those moments, you're only getting billed for storage. However, this tier does have some slight delay in compute warm-up after those paused idle periods. If you can't afford that delay, you can use the provision compute tier, and there's also a hyperscale service tier, which gives you the ability to auto-scale to up to 100 terabytes, and your storage grows as needed. In this case, you're not limited to the resources available on a single node, and this can be really useful if you have large databases on-prem and want to move to the cloud. Next is SQL Server on virtual machines, which is a relational database management system, which gives you up to 3 years of free extended support for SQL Server 2008 and 2008 R2, in case that's what you're running now. And it has 100% code compatibility when you lift and shift SQL Server to the cloud. And it also offers automatic security updates, and it uses another service called Azure Backup to restore the database to a certain point in time if something happens. You'll also get protection for your data at rest and in transit. Next is Azure Cosmos DB, which is a non-relational database offering. It has automatic and instant scalability, as well as open source APIs for MongoDB and Cassandra. For redundancy and compliance, it has multi-master replication and global distribution, and it integrates with Azure Synapse Analytics for near real-time data analysis, so you don't need to move your data around or impact performance. And the Cosmos DB programming language is based on JavaScript, so if you already know JavaScript, that could be a plus. And the last offering we'll look at is Azure Cache for Redis. This is a caching layer before your database or storage layer in your application architecture, and it works well with Azure SQL Database and Azure Cosmos DB. In this scenario, data is stored in memory instead of on disk, so it's much faster to retrieve. According to Azure, you can store and share database queries, results, session states, and static content. So if you have thousands of users using your app simultaneously, this can help you with that. And it also offers automatic patching, scaling, provisioning, and updates. And here is a list of Azure's compliance certifications. They have over 90 of them, and according to Azure, they have more compliance certifications than any other cloud provider. Okay, now we'll briefly take a look at a couple of the other competitors on the market. First is going to be Google Cloud Platform, which has 4% of the market share. Google is known for its strength in deep learning and AI, machine learning, and data analytics capabilities, which is related to its work with Google Search. Also has a focus on fast response time, scaling, and load balancing, and it's known for its expertise in open source tech, including containers because of its role in Kubernetes development. However, you probably won't see the same enterprise relationships as you would see with some of the other cloud providers, and they also have a smaller data center footprint, but they are growing that. Next is Alibaba Cloud, also called Aliyun, which has 8% of the market share and is based in China. Originally, this cloud was created to support Alibaba's e-commerce platforms, but it is growing steadily as a competitor. Alibaba has plans to invest $28 billion in infrastructure over the next 3 years, meaning they have deep pockets in this business. This money is primarily going toward more data centers, a custom operating system, and semiconductors for hardware. Alibaba also offers hundreds of solutions, which is more than AWS, but that may just be more about how they cut those offerings and less about breadth and depth. But in any case, you might really want a partner's help here to navigate all those offerings. One feature of Alibaba Cloud is specialized intelligence solutions called Brains. And they have those for areas like smart cities, medicine, manufacturing, aviation, environment, and finance. CityBrain is currently deployed in Hangzhou, a city of 21 million people, and uses data from sensors to manage traffic flow, public transportation, and public safety. And last, we'll look at IBM Cloud, which holds 4% of the market share. As you may know, IBM is a 109-year-old company that recently split into two. The company now called IBM will focus on hybrid cloud and AI, while the new company called NewCo, temporary name, will focus on managed infrastructure services. And from this move, it's really clear that IBM is betting its business on this. If you're interested in hybrid cloud offerings, this is one area IBM is strong in. They're also focused on developing specialty clouds right now. For example, IBM Cloud for Financial Services. To make this cloud, they worked with Bank of America and other banks, and it offers a simplified compliance story for organizations in that industry. Now I'd like to talk about using a multi-cloud approach, and to do so, I'll mention the JEDI contract. This was a $10 billion contract from the US Department of Defense that eventually went to Azure, but is still causing a lot of drama amongst cloud providers and their lawyers. When Azure was awarded the contract, some critics of the process argued that such a large contract should not be awarded to a single company, while proponents said using only one provider would eliminate glitches in military systems and streamline communications. So that brings us to talking about a multi-cloud approach, which is when you have some of your workloads and applications running in one cloud and others running in another cloud or several other clouds. Let's first talk about the potential pros of this model. The first is that you would be supporting diversity and competition in the market by distributing where your money is going, and competition is a good thing. Next is the power of choice in this model. With it, you can use the best offerings from each cloud provider. That means if one cloud doesn't have an offering you need, you may be able to use another. Also means that you can shop around for the most cost-effective options. And another potential pro is you'll be in good company here because it's a popular option. Around 85% of companies are doing the multi-cloud approach right now. For some potential cons, one is communication, because you're talking across companies. This can be slower and less efficient. Also, you might have services that need to communicate across clouds, and that might be trickier than services talking with each other within the same cloud. Another potential con is that you may start thinking you can easily move your apps between clouds quickly if you're faced with pressure under outages, and that's probably not true. You should plan to keep your applications in the cloud that they are in and only move if really necessary. Lastly, you'll need to consider how to upskill and hire engineers so you have people who are productive in the different environments you run your workloads in. Now we'll move to the last section and discuss what tools and strategies you can use to help make the cloud migration process a smooth transition. One thing to note is that cloud providers are going to invest a lot in migration tools because they really want people to migrate and they want you to feel confident doing so. So you're going to get a variety of tools to choose from. They range from free, simple things like this flow chart, for example, that kind of asks you yes or no questions until you arrive at a service, to things like pricing calculators where you note the services you want and at what scale and you get an estimate. The one on the left is AWS, the one on the right is Azure. Others are full-fledged services that usually require an account with the cloud provider and that help you dig a little deeper. We'll take a look at some of these services provided by AWS, but most cloud providers are going to have similar offerings. And I'll try to kind of breeze through these just for time. First offering is called Migration Evaluator, and this helps you get recommendations for right size and right cost compute. This tool helps identify where you are maybe over provisioning instances on-prem and what the more cost-effective AWS alternative is. Next is CART, or Cloud Adoption Readiness Tool. This is a 16-question survey to evaluate your organization's current readiness. It'll give you an assessment at the end, as well as best practices and some of your current strengths and weaknesses. There's also AWS Migration Hub, which offers a centralized location for tracking your migration progress and gives you visibility into the status of your migration across different applications, as well as various key metrics for those applications. Next is AWS Application Discovery Service. This is another tool that helps you gather information about your on-prem data centers. It will collect data on behavior, usage, and configuration from your servers, and you'll get dependency mappings and so on. Also helps you determine your total cost of ownership for AWS. There's also AWS Control Tower. This gives you a way to set up a quote-unquote landing zone, which is kind of like a boilerplate or just a starting point for the underlying infrastructure, which is provided as code. Another tool is Cloud Under Migration. This is an agent-based service, and it replicates source machines into a staging environment in AWS. It does so without any downtime. The applications are still running at the source. And once you're in AWS, you can make your changes there. And AWS Database Migration Service is another tool. It's used to help migrate your database to AWS. This can be like a homogeneous migration, for example, Oracle to Oracle, or heterogeneous like SQL Server to Amazon Aurora. And last is AWS Data Sync. This moves data from on-prem storage to AWS storage and removes the need to write or use scripts. It's a good option for moving data if you have the available bandwidth. So yeah, this is just a sampling of services, and you should use any combination of them that you need, and also more services to make sure you feel confident in your move. Now I am ready to move into migration strategies, but I'm going to do a time check to see if that is okay. Can I get a...
Hi, Sandra. We're just 10 minutes from the top of the hour.
Okay. Do we have time for me to go into it then?
Yep, let's do it.
Okay, let's do it. All right, so last topic, we're going to cover is migration strategies, and these have just been recommended by the cloud providers and the enterprises that have made the move themselves. The first strategy is to define objectives, and to do so, you can start by deciding what your key values are. There are many potential benefits to the cloud, but what are the ones that are most important to you for moving to the cloud? One is probably going to be cost optimization, but what else? Make sure you're getting stakeholders, decision makers, and engineers all on the same page about priorities, and also get a clear financial model of what the move will look like and what business values you expect. Next is to set measurable goals. Ask questions like, what are the key metrics you're going to use to measure your organization's success by? This could be cost optimization or reliability or productivity, but just make sure you have very clear metrics so you can actually measure what progress looks like. And by doing so, you can keep the team on track and stakeholders invested and just motivate everybody. So make sure that you're using a focused approach as opposed to an organic one. Don't just say, oh, we'll get started and see how it goes. That could lead to muddled outcomes. Be as clear as possible at every step of the migration process. Next strategy is to assess the situation, starting with determining what parts of your architecture are currently cloud ready. What parts are decoupled? Where is the low-hanging fruit where you can have easy gains? Do you have some licenses that are about to expire? Some hardware that is at end of life and needs to be recycled? And the counterpart to that, what parts are the least ready? Which ones are tightly coupled? Where do you have legacy code that's running on an older operating system or database version? What parts will have less benefit from a move? And you also need to assess what services you'll need. Whether you go single cloud provider or multi-cloud approach, you need to know what services you're going to be using and how they will work together. Another part of the assessment is determining your current costs. Get the total operating costs of your current infrastructure and software. Then you need to get the projected costs. Use tools like the ones we discussed to figure out what it'll probably cost you to move, figure out that difference and compare it to your business goals. Finally, decide what migration tools you can use to help you. What tools, the ones we discussed or others, can use to make this transition easier, and what services and frameworks are you going to rely on. Next strategy is to level up. You can do this by first building out a training curriculum. After you've picked your services, build a strong curriculum around the core ones. Your team needs a solid education to make the move successful. Remember, you can use Pluralsight courses. There are plenty of those. Also, cloud providers are going to have their own learning platforms. And also consider sponsoring your team to get certifications from the cloud provider or providers you've chosen. Next is actually to move to team education. Give your team ample time to go through that curriculum and opportunities to test themselves. Investing at this stage will pay off immensely when it comes to time to implement. You may have to spend more time here, but that can help you avoid costly mistakes at the end that lead to time lost and lost savings. And consider organizational education as well. Give your opportunities to educate stakeholders and decision makers. This way the knowledge can trickle up. Also, at least this way, your organization is somewhat familiar with the components of the move and core services. Next strategy is to partner up. Bring on partners, consultants, migration experts, solutions architects if you decide you need them and you can expend the budget. Every cloud provider is going to have a network that they work with for this kind of stuff. But yeah, like a strong education, the investment in this is going to probably be worth it if it means you can set up your architecture correctly the first time. Next is planning. Set up a timeline, be realistic, have clear milestones, and make sure you allocate ample time for testing and security configuration, and communicate these milestones with the business as you hit them. Next is to expect the migration to happen in phases. Things are going to happen in waves, not all in one go. Once you've done a wave, go back, reassess, learn again, plan again. Test your infrastructure and configurations heavily between the waves. And as much as possible, plan for complexity. Schedule time between those waves to work through unexpected issues and have really reliable ways to revert quickly, backtrack, pause, etc. The last strategy before the move is to prepare for it. Prepare your landing zone and your test environment. Use those landing zone tools that we mentioned to configure that. Then create a proof of concept within the cloud environment. This is just where you have all the pieces and the services and resources fitting together in the cloud, even if it's just on a small scale. And finally, prepare how you're going to do your testing, how you're going to test your workloads, and furthermore, how you're going to stress test beyond your normal traffic to see what happens when you get spikes. Okay, now let's talk about a couple things to do after you've actually made the move. The first thing to think about is oversight and logging. Make sure you're monitoring for degradations and interruptions. If you notice these, translate this to revenue impact so you can see what your losses are and fill in any gaps that you might be missing in monitoring, analytics, alerts, and so on. Also do a governance check. Make sure you're tracking your organization's governance practices and identify gaps if there might be any, and also create a recurring governance process, check-in so that you're doing this repeatedly and monitoring your status. And the very last tactic is to optimize. Monitor your infrastructure and resources, and then resize to optimize cost even further. And just keep up with the new services, solutions, and deals that as they come out, because these cloud providers are always competing with each other to be more effective and cost efficient. All right. Yeah, thank you. That's it. Those were some of the strategies, tools, and concepts and providers and offerings that you can consider if you're planning a move to the cloud. It's a big change, but by doing the right research and using the right tools, you can make it as smooth as possible. Yeah, so thank you for your time and for being here today. Hope I was able to share some insight into what a cloud migration might look like for you and your organization.
Thank you so much for that, Sandra. That was extremely insightful. Now, rather than me doing a Pluralsight product pitch at the moment, I want to get straight into a couple of questions that we've got here. I've got a question here around government projects, Sandra. So in terms of using cloud, cloud that is based in a different country, how can we set up a cloud system sufficiently to comply with the laws and the processes, etc.?
Right. So yeah, you have to know what your own requirements are, what your customers' requirements are, what your government's requirements are. And then you also need to know about the requirements that are in that country. So for example, if you're going to use Alibaba and you don't live in China or your company's not run out of China, you need to consider what, special compliance issues they have. I know with Alibaba, you have to use like a government ID. There's like, yeah, I think it's called a government ID, but you may need to run things differently there. So you'll want to just know you just have to know what your compliance requirements are and then check that against the cloud that you're using.
Great, thank you. And I've got another question here just asking, how long does cloud migration usually take, give and take all of the complexities that we've discussed today as well?
Yeah, so that is it definitely depends. There's a really big range. It could, if you just have a few workloads or one application to migrate, it may be a few months up to a couple years. What I would say is just, definitely don't rush it because you do want to try to do it right the first time if you can. And it will save you a lot of time down the road if you don't have to re-architect and rebuild. So it's definitely one of those things where if you invest earlier in doing it correctly the first time, it's going to pay off. And then you'll have a solid infrastructure that you can build upon. And yeah, if you make sure that you don't have a lot of cross dependencies, like things are kind of standalone as much as possible. It just makes it a lot easier to add new features, build out new products, launch new applications. That also applies to your, build strategies and your deployment strategies. You want those to be really solid and you want to put a lot of time into those because that's really going to pay off later. Same with how, your revert strategies and, what are you going to do if you have to reroute? Those, pay off because those things are going to come up. So you just want to have a strong infrastructure for that.
Fantastic, thank you. I've got one question here. Is Amazon ECS basically what hosting providers categorize as VPS, which is virtual private server?
Yeah, so I have not heard the term virtual private server. Yeah, let me just go back to that slide.
I guess it's just one of those terms that's not extremely globalized.
Right, yeah. So when I would say I don't know.
That's fine.
I don't really want to say yes or no on that because I have not heard that term. Sorry.
Sounds good. Perfect. Look, we are at the top of the hour, everyone. That is unfortunately what we have time for today. Sorry if we were not able to get to your questions. I'll be sure to share them with Sandra, and she'll be able to reach out to you, or I'll be able to reach out to you with some information and answers around that. And also, obviously, feel free to get in touch with Sandra via LinkedIn if you want to learn more about, Spotlight Consulting as well. And obviously, if you want to learn more around Pluralsight, and how we can help upskill and cross-skill your team and raise their competence around cloud, You can go on pluralsight.com, or you can reach out to myself directly. I've left my email in the chat messages. And again, you can ask your questions and give us feedback in the exit survey, which you will receive separately. So that's all we have time for. Thank you again, Sandra, for joining us your evening. That was very, very beneficial. I'm sure everyone on the call will agree as well. Thank you to everyone for joining as well. I hope you enjoy the rest of your week, and we hope to have you back on another session very soon. Thanks a lot. Have a great day.
Thank you, everyone. Thank you.